On December 13, 2022, at 8:31 a.m. local time in Palmdale, California, the SOFIA observatory departed for its final flight. Flying the aircraft were pilots Liz Ruth and Jim Less, along with flight engineer Tim Sandin. After a symbolic flyby, SOFIA's final crew landed at Davis-Monthan Air Force Base in Tucson, Arizona, where the aircraft and telescopes will be retired in the Pima Air and Space Museum for public display. SOFIA stands for the Stratospheric Observatory for Infrared Astronomy, and it was a joint project between NASA and the German Aerospace Center. This one-of-a-kind flying observatory was carried by a Boeing 747 SP, which was specially modified to accommodate its 2.7-meter reflecting telescope. NASA acquired the aircraft in 1997, which had previously flown commercial flights with Pan Am and United Airlines before its acquisition. Using an aircraft like the Boeing 747 SP gave SOFIA several unique capabilities over ground-based telescopes. By flying at an altitude of 45,000 feet, SOFIA was above 99% of Earth's atmosphere, which otherwise blocked infrared light from hitting the ground. The observatory's ability to fly also made it possible to conduct observations in both northern and southern hemispheres. While Palmdale, California were its home skies and the primary site of observations, SOFIA had been frequently deployed to Christchurch, New Zealand, where it would observe celestial objects and phenomena that was otherwise not visible outside of the southern hemisphere. SOFIA was deployed to Christchurch for the seventh and last time in June 2022, just a few months before the observatory would make its final flight. By gathering data at far infrared wavelengths, the overnight flights of SOFIA have studied the formation of new solar systems, nebulas and galaxies, and other phenomena in space. Here are some of its greatest findings. In April 2019, SOFIA detected the first type of molecule in the universe, helium hydride. The telescope found the molecule inside the planetary nebula NGC 7027, which is about 2,900 light-years from Earth. For decades, scientists had struggled to find the existence of this molecule outside of a laboratory, which was believed to have formed a relatively short 100,000 years after the Big Bang. In 2020, SOFIA confirmed the existence of H2O or water on the sunlit surface of the Moon. The water molecules were detected in one of the largest craters on the Moon that can be seen from Earth, Clavius crater. Although the amount of water detected in this location was very small, around 100 times less water concentration than the Sahara Desert, the findings suggest that water is not only limited to the cold and dark regions of the Moon, which is an important discovery for a resource that would otherwise be valuable in potential space exploration missions in the future. Through findings within our home galaxy, SOFIA has helped scientists differentiate between active and quiet black holes. Harnessing the observatory's modular design, scientists installed and used the High-Resolution Airborne Wideband Camera Plus, or HAWC Plus, to measure the magnetic fields at the center of the Milky Way galaxy. Combined imagery from these new cameras shows how these magnetic fields are channeling gas into an orbit around the Milky Way's black hole, potentially explaining the relative quietness of our galaxy's black hole versus the hungry active nature of other black holes in our universe. Finally, SOFIA captured this amazing infrared image of the center of the Milky Way galaxy, revealing never-before-seen features of the galaxy that we call home. The 2020 Astrophysics Decadal Survey concluded that relative to its cost, SOFIA has not been scientifically productive or impactful over its duration, and recommended that NASA end its operations by 2023. NASA also stated within its budget documents that dramatic improvement in SOFIA's scientific productivity is not expected, which ultimately led to the retirement of the program. With SOFIA retired, scientists are concerned about the loss of knowledge and access to far-infrared research in astronomy. While the proposed Origins Space Telescope could help astronomers regain access to far-infrared research, these proposals remain in a distant future, with its potential launch set far in 2035. For now, advancements in infrared astrophysics will continue to progress through the recently launched James Webb Space Telescope, and the discoveries and data of SOFIA will have left behind a legacy through its massive contributions towards challenging and expanding our understanding of the universe.